Most people think of browser extensions as things they added for themselves: an ad blocker, a password manager, maybe a screenshot tool, private, local, nobody else's business. And for the most part, that is true, except for one detail that surprises people the first time they see it demonstrated. A website can often work out which extensions you have installed without asking, without any permission prompt, and without the extension doing anything wrong. Today I want to explain how that works, why the specific set you carry is more identifying than any single one of them, and what it means for anyone running separate browser profiles. Quick note on framing before I start. I run real proxy and cloud phone farms, and I test how these browsers handle identifications. This is third person and defensive the whole way, how the technique works and how it gets defended against, not a recipe against any particular site, and no undetectable promises. This is one more signal, and the useful outcome is understanding it rather than pretending it can be switched off. Start with the most direct method because it is also the oldest. Many extensions ship files that a web page is allowed to load. Images, style sheets, small scripts, whatever the extension needs to inject into pages it works on. Those files live at addresses that begin with a special scheme and then the extension's own identifier, which is a long fixed string that is the same for everybody who installed it from the store. So a page can simply try to load one. If the file loads, that extension is installed. If it fails, it is not. No permission, no interaction, and the check takes a few milliseconds. Run that against a list of a few hundred popular extension identifiers, and you have a fairly complete inventory of what somebody is carrying. Browsers have pushed back on this over the years, and the pushback is worth understanding because it is partial rather than total. The main defense was to stop those files being loadable by default, so an extension now has to explicitly declare which of its files the web is allowed to reach. That helped a lot. But plenty of extensions still need to declare some, because that is how they function, and any file that remains reachable is still a probe. Some browsers went further and randomized the identifier per installation, so the address is different for every user. That genuinely breaks the simple inventory check, and it is the better fix, but it is not universal across browsers or across extensions. The second method does not probe anything, it just watches what happens to the page. An extension that modifies pages leaves evidence in the page. An ad blocker removes elements, or hides them, or prevents certain requests from completing. A password manager injects an icon into login fields. A coupon tool adds a button at checkout. A dark mode extension rewrites colors. A script blocker stops things loading in a pattern that is quite distinctive. A page can inspect itself. It can plant a decoy element that looks exactly like an advert, with the class names and dimensions ad blockers key on, and then check a moment later whether that element still exists and is still visible. If it vanished, something removed it. It can check whether the elements it created are still the colors it set. It can watch for nodes it never created appearing inside its own form fields. None of that is exotic. It is a page reading its own contents, which every page can do. There is a variation on that second method that deserves a mention because it is quietly clever. Instead of planting one decoy, a page can plant a whole spread of them, each matching a different filter list, and then see which ones survive. Ad blockers do not all block the same things. They subscribe to different lists, and those lists differ by region and by preference, so the pattern of which decoys vanished and which stayed is not just evidence that you block ads, it is a rough fingerprint of which blocking setup you run and sometimes which regional list you subscribe to. That is considerably more specific than a yes or no. The third method is timing, and it is subtler. Blocking a request is not free. An extension that intercepts and cancels network requests changes how long certain things take, and it changes them in a consistent way. A page can request a handful of resources, some of which are on well-known block lists and some of which are not, and compare how long each takes to fail or succeed. The shape of that timing profile says a lot about whether something is filtering and often which filter list it is using. So those are the mechanisms: probe reachable files, observe changes to the page, and measure timing. Now the part that actually matters, which is why any of this identifies a person. One common extension tells a site almost nothing. A very large share of users run an ad blocker, so learning that you have one narrows you down barely at all. The identifying power is in the combination and in the rarity. Think about it as a set: an ad blocker, a specific password manager, a particular translation tool, a niche developer utility, and something regional that only exists in one language. Individually, unremarkable. Together, that exact 5-item set might belong to a genuinely small number of people on the internet. And unlike a lot of fingerprinting signals, this one is remarkably stable. People do not change their extensions often. The set persists across sessions, across profile clears, across IP changes, which makes it a durable link rather than a momentary observation. There is a second angle that matters more for anyone running multiple profiles, and it is the opposite problem, the empty profile. A fresh automated browser profile typically carries no extensions at all. No ad blocker, no password manager, nothing. That sounds like the safest possible state, and in a population sense it is unusual. Real people accumulate things. A browser that has clearly been used for a while, by a person with a history, tends to have picked up at least one or two. A profile that is perfectly bare every single time, across many accounts, is its own pattern. Not proof of anything on its own, but another value that does not look like the population it claims to belong to. And then the version of that which really does cause problems, the shared set. Someone sets up profiles for a lot of accounts and installs the same 3 extensions in every one, because they are useful for the work. Now, every one of those accounts carries an identical, slightly unusual extension fingerprint. Individually, each profile looks fine. Collectively, they are wearing a uniform. This is the same failure that shows up in every other layer of this subject. The values were not wrong, the sharing was. There is a mobile angle to this that catches a particular kind of setup, and it is worth spelling out. On phones, extensions are rare. Most mobile browsers either do not support them at all or support a small curated handful, and the overwhelming majority of phone users run none. So a profile that claims to be a phone through everything else, the user agent, the screen dimensions, the touch capability, and then exhibits the unmistakable behavior of a desktop ad blocker rewriting the page, has produced a contradiction that needs no clever analysis to spot. It says phone, and then it does something phones essentially never do. The same logic applies in reverse to the enterprise case, which is less common but real. Some environments push a fixed set of managed extensions to every machine in an organization, and that set is distinctive. A profile carrying a corporate security extension alongside a personal password manager and a consumer coupon tool is describing a machine that belongs to 2 different worlds at once. Plausible, occasionally, but not 50 times across 50 supposedly unrelated accounts. It is also worth knowing that extensions have versions, and versions leak. An extension that injects a script often injects one that is recognizable, and the specifics of what it injects change between releases. So the observable behavior narrows not just to which extension you have, but sometimes to roughly which version of it, which makes the set finer grained than most people assume. And because people update on their own schedule, that version detail drifts in a way that is individual rather than shared. Pharmacopy. Finally, remember that this signal does not sit on its own. It correlates. The extension set is compared against the platform, the language, the time zone, and the rest of the picture. A regional extension that only exists in one country, running on a profile whose network says somewhere else entirely, and whose language settings say a third place, is 3 signals disagreeing rather than one odd extension. That is the shape of nearly every finding in this subject, and extensions are simply another column in the same table. So how is this defended against, and what are the realistic limits? The honest answer starts with an uncomfortable point. This is one of the harder signals to neutralize, because the evidence is not a value the browser reports. It is the observable consequence of software actually doing something to the page. You cannot spoof your way out of an element having been removed. It was removed. The page can see that it was removed. What good tooling can do is control the surface. Keep the extension set deliberate rather than accidental. Keep it plausible, meaning close to what an ordinary user of that profile's supposed type would carry. And critically, do not clone the identical set across every profile, because that turns a weak signal into a strong link. Browser-level defenses help with the first mechanism. Randomized extension identifiers break the direct probe, and browsers that support that are meaningfully better here. Some extensions can also be configured to be less visibly interventionist, though there is an obvious trade-off, because an ad blocker that does not block anything is not an ad blocker. The practical framing I would offer is this. Decide what the profile is supposed to be, and let the extensions match that story. A profile representing an ordinary person can carry ordinary things, and probably should. A profile that needs to be maximally quiet should carry as little as possible, and accept that carrying nothing is itself slightly unusual. What you want to avoid is the middle, where a bare automated profile suddenly sprouts a distinctive set of tools that no ordinary user of that description would have, and then wears that same set across 50 accounts. And as always, test it rather than assume it. The probe check and the decoy element check are both easy to run against your own profile, and they will tell you in a minute what a site would learn. I test these browsers on real multi-account setups, and the written reviews and the picks I actually trust are all at antidetectbrowser.org. The reviews cover what each tool actually exposes rather than what the marketing page claims. So the short version: sites detect extensions three ways: by probing files the extension makes reachable, by observing the changes an extension makes to the page, and by measuring the timing of requests it interferes with. One popular extension tells them little, a rare combination tells them a lot, and it is unusually stable over time. A perfectly empty profile is its own kind of unusual, and an identical set cloned across many profiles is the thing that actually links accounts together. Full written reviews and tested picks are at antidetectbrowser.org, and if this was useful, subscribe for honest, tested anti-detect browser reviews.